Hello everyone. Thank you for joining AWS Summit Online ASEAN and welcome to this session. I'm Tony Prakoso. I'm a senior developer advocate with AWS covering for ASEAN. And I'm super excited to be here today. And in this session, we're going to be talking about how we can replicate the AWS DeepRacer architecture to Amazon SageMaker. This session provides a set of information for you who want to go beyond and add some customization more than what you will find in the original AWS DeepRacer console. Some important notes before we get started. This is a session with level 400, which we expect you to have joined level 200 and 300 level to get yourself familiar with basic information and terminologies used in AWS DeepRacer. And they're also helpful for you to get more understanding from this session if you have configured and play around AWS DeepRacer console, such as building your vehicle on the garage mode, building your reward function, train, evaluated your DeepRacer models, duplicate the model for improvement, and also take a part in the DeepRacer virtually. This session is also helpful for those who want to learn under the hood of DeepRacer architecture and how Amazon SageMaker plays a vital role in bringing DeepRacer into life. And if you do, then you're in the right place. Okay, moving on. What we will discuss in this session is we are going to use AWS DeepRacer architecture and we are going to replicate it in Amazon SageMaker Notebook. Then we're going to do a deep dive into one of the concepts in deep reinforcement learning. We're going to discuss the neural network architecture behind DeepRacer agents. And then we're going to learn about how we can take our learnings from AWS DeepRacer, the reward function, neural network modifications, and apply it to real-world problems. And applying reinforcement learning to real-world problems is an interesting topic, as we will take you to how our customers use deep reinforcement learning to provide state-of-the-art solutions for their specific challenges. Sounds good? Let's get started. Before we begin, some exciting announcements about the 2021 racing season. First of all, the AWS DeepRacer League 2021 season will introduce Open and Pro racing divisions. The Open division is where all racers begin their machine learning journey. Racers can earn their way into the Pro division each month by finishing in the top 10% of the time trial results. The new racing divisions include 5 times as many opportunities for racers of all skill levels to win prizes and recognition for participation and performance. Participating in Open and Pro Division races can earn you new digital rewards. Open Division rewards participation each month with new vehicle customizations and other rewards. And the Pro Division celebrates competition and accomplishment with DeepRacer merchandise, DeepRacer Evo cars, exclusive prizes, and qualification to the Championship Cup at reInvent. In addition to that, pro racers can also participate in special events with partners such as Formula One with special rewards and guests. Hopefully, these new features excite you as you have more opportunities to win prizes and recognition for participation and performance. So let's start this session with the SageMaker Notebooks and take a look at the architecture behind AWS DeepRacer. There are 2 main components behind AWS DeepRacer. 2 core services that power DeepRacer are Amazon SageMaker and AWS RoboMaker. AWS RoboMaker is a simulation environment that supports Amazon SageMaker. Amazon SageMaker does all the training that is needed for your reinforcement learning agent to become intelligent throughout its learning. And AWS DeepRacer uses Amazon SageMaker in the background, while Amazon SageMaker orchestrates all the services underlying DeepRacer. So let's take a look at what you can do today with AWS DeepRacer and how you can go beyond that with Amazon SageMaker Notebooks. As you know that in DeepRacer, you are given multiple tracks. And all of the races are using these tracks, and you can compete using multiple tracks. Now, one of the most amazing features that you can have by leveraging Amazon SageMaker Notebook is that you can create your environment. And by having flexibility in creating tracks, you can also modify your vehicles by adding new sensors to capture, navigate, and interact with your custom environment. In the current version of the DeepRacer agent, it has 2 cameras, but also it has a LiDAR sensor. But with SageMaker Notebooks, you can add additional sensors, such as proximity sensors. And with this kind of flexibility, your implementations can go beyond other than provided by the default in the DeepRacer console. SageMaker Notebooks also enables you to take your training to the next level. With the notebooks, you can create multiple simulation environments, and this is the most wanted feature, that you can do training and learning for your neural networks on all the simulation environments at the same time. And this means that you can iterate faster, and you can quickly check whether your reward function is improving, and use that as the base for the next iteration. And this is super useful to accelerate your model, especially if you're going to compete in races. And finally, you can also evaluate your models in various tracks. And the most important of all, one of the core concepts of deep reinforcement learning is the neural network architecture that enables you to learn a certain track. And this is exactly what we're going to cover in this session. We will discuss how to change the neural network, learn the pros and cons of modifying the neural network on our reward function, and improving the performance of your reinforcement learning agent. Before we do a deep dive into modifying your neural network, let's refresh how our reinforcement learning agents learn. Reinforcement learning works in a feedback loop. At the very end, we have our neural network, and this neural network is initialized by core random weights. And these random weights are first used to gather experience using the simulation application, and the simulation, as you know it, runs in AWS RoboMaker. Now, after these experiences are gathered, we push them through a gradient ascent. And gradient ascent learns the new neural network weights by maximizing a cumulative discounted reward function. The cumulative discounted reward function is critical because this is where the reinforcement learning agent learns. So it's not only learning the action it has to take here and now on the track, but it's looking ahead. So in this case, our agent will learn something like, if I try to go over the track and do an action, what is the cumulative reward I will get? And this is the correlation between reward function and the neural network. It enables the agent to learn the maximized reward based on the reward function that you have crafted. Now, this concept is very similar to how we would come up with different models when you're applying supervised learning or unsupervised learning to data labels. And in this case, your data is the cumulative discounted rewards, and the data that you're gathering is the experience that you obtain from your simulation environment. Let's take a look at what are the pros and cons of using deep neural network architecture. First, the pros of using deep neural networks are that you can potentially get a better approximation. And this improvement on approximation leads to higher rewards in a shorter amount of time. And this advantage can be used for a variety of reward functions. So if you look back at different kinds of reward functions that you have, and what we have seen in our experiments is that the reward function is not linear related. It has these on and off moments. For example, you get rewards if the agent is on the track, and no rewards if the agent is off the track. The agent gets rewards at the end as a bonus when it completes the track, as opposed to getting progressively more and more incentive as it goes around the track. And for these types of reward functions, based on our experiments, we have seen that deeper neural networks provide better performance and higher rewards around a faster amount of time. Now let's review what are the disadvantages of having to use deep neural networks. As you all know, shallow networks have a smaller number of layers, and they can be trained much faster, obviously. On the other hand, if you have deeper networks, they are going to take longer to train. And this is where SageMaker could become quite handy to handle this kind of challenge. SageMaker provides you with the different kinds of GPU instances, and you can quickly turn this disadvantage into an advantage by using various kinds of GPU instances. SageMaker provides a different kind of GPU instances at various cost levels, and you can get the most out of this disadvantage. Another disadvantage is in the case when you do simulation to reality transfer, we have seen that some of the deep neural networks do not transfer as well into the real world due to the delays it takes for these neural networks to run interference on the AWS DeepRacer device. Let's consider an example and look at the plots that we will see if we look at the progress. So imagine that we have a reward function that is getting an incentive to the agent. In this case, it's getting incentive when it's on the track and no incentive when it went off the track or when it hit an object or one of the cars. And it only gets reward when it completes the track without hitting any of the stationary or moving objects. So this means that we don't have a linear reward function, but it's a relatively simple reward function. Now what we have on the screen here are two graphs. On the left side, we have a shallow network, and on the other side, we have a deep neural network. Now let's evaluate the progress. On the y-axis, and this indicates the progress that the agent makes as it's learning this new reward function. So if you look at these two curves on the shallow network, after 400 episodes, our vehicle, our agent, can learn to go over 60% of the track. On the other side, when we look at after 400 episodes, our deep neural network can do 80% of the track. And this means it achieves a higher progress rate across the track. Another thing, previously we mentioned that it's going to potentially take faster to train, depending on how deep your neural network, and depending on your function as well. So if you look at the 60% progress, which means these agents reach 60% coverage across the track, we can conclude that the deep neural network can achieve this twice as fast compared to the shallow neural network. So this is one of the advantages that we have seen if we were to create the deep neural network for an agent as opposed to shallow neural network. Now, before we deep dive into how we can modify the neural networks, let's take a look at what actually the neural network looks like. In this example, we're going to use Evo as the base, where we have two cameras and one LiDAR sensor. The two cameras are capturing a 2D image, and the neural networks are going to have an input for this and pass it through convolutional neural networks. So these convolutional neural networks enable these stereo cameras to learn to look at different parts of the track, and also to learn not to go off the track, not to hit an object, and move around. And same thing with the LiDAR sensor. But now imagine that when your car is going, it's probably going to see things first with its cameras. But when they are passing them, it's going to see them with the scanning LiDAR. The scanning LiDAR is going to be a one-dimension vector, and we're going to pass the input that is coming from the LiDAR to 1D layers. Now, once we have our 2D convolution of neural networks and LiDAR, we're going to combine all this information in the middle layer. Now, as your car is moving forward, it is seeing the cars in the front, and then it is passing, it is seeing the cars in the back. So you will be combining all this information that is passed through several layers of convolutions and one-dimensional convolutions and merge them in the middle layer. As for the output layer, it shows the probability of the action list. And one thing to note here is that irrespective of the sensor data that you have, your agent is limited to the number of actions it's going to make, and the number of actions is tied to the number of nodes in your neural network output. So let's get you up and running to build your DeepRacer architecture with SageMaker Notebook and switch to the demo. This demo is based on the self-paced online workshop that you can access at this link. To make everything easier for you to set up, we already provide you with a CloudFormation stack. This CloudFormation stack will provide all required resources for you, from SageMaker, RoboMaker, S3 Bucket, Kinesis video streams, CloudWatch, and VPC. So you might want to make sure that you have sufficient capacity in your account, and if you hit the limit, you can always request to increase the service quota by contacting support. Let's create the stack. This stack requires you to input some values, such as the S3 bucket name and the Amazon SageMaker Notebook name. Then, we can move forward to acknowledge that CloudFormation might create additional IAM resources and create the stack. It takes a couple of minutes for CloudFormation to complete, and you can view the progress on the CloudFormation dashboard. Once it's done, you need to go to Amazon SageMaker dashboard. Select the notebook for DeepRacer that we just created and open the Jupyter notebook. Then you need to navigate to this folder and you will find the Jupyter notebook. This workshop uses TensorFlow, so you might want to use the proper kernel. And there you go, you have the notebook. Before you start working with this notebook, you might want to change few global variables and imports in the workshop setup section. Now, let me guide you on how to use this notebook. I'm going to change this notebook with the notebook that I have configured. This notebook is structured into sections. The first section is the workshop setup. The next section is the action space and sensor combinations. Then the most interesting section is how to update the neural network architecture, like we have discussed earlier between shallow and deep network. Then creating the reward functions, training the model, creating the multiple rollouts, and evaluation. So this notebook is pretty comprehensive. So let's go to the first section, the setup. Like I mentioned before, you might want to change few variables to get you up and running. If you don't have any GPU instance on your EC2, you can change to use CPU instead, like what I did here, by changing the instance type variable. Then it will prepare all variables such as the S3 bucket, VPC, and also the SageMaker session. The next section in this notebook is for you to upload action spaces and reward functions. I will pause this for a while since I like to show you how these files look like and how to create your custom files both for reward functions and action spaces. First, action spaces. Now, this is pretty interesting because you have the flexibility to change the actions and also the depth of the neural network based on the discussion that we just had between shallow and deep neural networks. Let's view the files. First, you can navigate into this folder. And within this folder, there is a set of JSON files. And the action space defines the specific actions an agent can take in both the simulator and physical world. Let's open a file and see how it looks like. In this file, you can define the steering angle, speed for the action spaces. And also, you can add a sensor such as a front-facing camera. To make selecting the file easier, the naming structure of this file starts with the sensors such as front-facing or stereo or LiDAR, follow with the depth of the network, then the action spaces, speed, and steering angle. Let's take a look at another file. If we go to the last line, you are given an option to choose the neural network. There are 3 values available for the neural network. The first value is the deep convolutional network. Second value is the shallow neural network. And if you want to use deep network, you can also change the value into this value. Alright, the next one is the reward function. To see all files for the reward function, you can navigate into this folder. Inside this folder, you will see there are few reward functions files just like what we have in the DeepRacer console. From the default function to object avoidance and head-to-head. And if you want to use your own reward function, you can create it by following the reward function structure and upload it into this folder. And you can then change the variable in the notebook to use your reward function. And the same thing also applies to the action spaces, which you can set the notebook to point out to the respective file. Once we have all the artifacts, this cell is going to upload everything into Amazon S3. Then it will go to the next section, training the reinforcement learning model. In this section, it will build and push the Docker image, which then will be used by the SageMaker to run the RL estimator later on. In this section, the notebook will set the role and also the CloudWatch. Now, the next line is the part when we instruct SageMaker to run the RL estimator. Here, we populate all variables that we have defined earlier, such as for instance type, base job name, metric definition, 2 hyperparameters. What I'd like to emphasize is that depending on the version of Python SageMaker library that you have installed, you might want to change a few parameter names if you're using version 2 of the library. For example, Train instance type has been changed to instance type in version 2. To see the list of the parameters, you can navigate to this page. And if we scroll down, you can see there are a few non-breaking changes for the parameter names. Also, in this section, we have just configured the Kinesis video streams that allows us to view the simulation both for training and also the evaluation. Next in this notebook is creating simulation in RoboMaker for model training, and set the RoboMaker simulation job parameters and start the training simulation. Now, at this stage, we already have started the training simulation, and once the training is done, what we want to do is evaluating the model. So in this section, we define the configuration for our evaluation. And in the next cell, we are starting the simulation with RoboMaker. Now, once the evaluation is started, we can view the progress on the Kinesis video stream. This is the Kinesis video stream page. And if we go to the video streams created for the DeepRacer, we can see the details. And if we go to the media playback, we will see the evaluation is in progress for our model. That's the quick overview of this notebook. Just to summarize what we have covered in this demo, this notebook helps us to do few things. First, to modify and augment the simulation environment and manipulate inputs to the neural network, to modify neural network architecture and run distributed rollouts for your model development. And also, this notebook shows comprehensive information and also technical parts on how you can use Amazon SageMaker Notebook instance to replicate AWS DeepRacer architecture. And this gives you flexibility and also granular control to help you build and improve your DeepRacer models. AWS DeepRacer is a learning journey. If you're following the 200 and 300 level courses, you've made yourself familiar with the fundamental concept of reinforcement learning and how you can implement that knowledge into building DeepRacer models. Now, to take your knowledge to the next level, let us give you a bit of perspective on how you can implement deep reinforcement learning based on the knowledge you had from DeepRacer to solve real business problems. And in the next slides, we'll cover a few use cases from our customers on how they implement reinforcement learning. Let's do a short recap on the deep reinforcement learning for AWS DeepRacer. In AWS DeepRacer, we learned about 4 different concepts. The first concept that you learned was the agent, and this agent uses a feedback loop to learn a long-term objective. Now, while doing that, this agent has a neural network, and what we discussed for today is heavily evolved on the architecture to get better performance from your reinforcement learning agent. Reinforcement learning agent makes observation and takes action. And AWS DeepRacer also uses a simulation environment, so you learn to use a simulation environment to experience how your neural network agents is going to perform. And your first task when it comes to AWS DeepRacer is how you need to craft and engineer reward function, and how the agent behave in different environments based on the logic that you structured in your reward function. This is just a quick refresher. And now let's see how these core components of deep reinforcement learning translate to different real problems and how to solve them. First use case, let's take a look at gaming. Capcom is one of the world's most leading video game developers, responsible for hit global franchises such as Resident Evil, Street Fighter, and Monster Hunter. And they have been building games faster using managed service on Amazon SageMaker. Now, if we go back to previous concepts of reinforcement learning, the neural network architecture, the basic foundation on how the game is built is by taking actions, which is similar to DeepRacer when it's going back and forwards, moving right and left. As you know, in AWS DeepRacer, AWS RoboMaker creates the simulation of the environment. And relating to the gaming technology, developers are using cutting-edge gaming agents such as Unity, where to return the reward based on the inputs. So this is very similar situation to AWS DeepRacer, but instead your simulation agent now is a gaming console, and your agent is playing a game, and it is beyond a racing game. Now, using these 4 core concepts and mapping into game applications, you can unlock many things. You can design better games before they go into production, or even you can understand how an agent can learn the game fast and maybe potentially find bugs in these games and improve your gaming environment before it goes into production. Now, let's see another use case and see how our industrial companies are taking this reinforcement learning and applying it to problems where they are getting better performance from their actual assets. Now, remember those 4 core components, and now our neural network agent is a real-time control system taking actions. The action could be pitching a blade of a wind turbine, and by learning how to pitch the blade in a simulation environment, you have high fidelity of physics. So we can model by pitching the blade how fast we're going to get wind and get the energy from the wind turbine, and use this as a reward to learn how to pitch the blades of a wind turbine better. So in this case, your DeepRacer experience is coming into the picture, where the agent is a neural network agent and is a controller taking action by pitching the blade. And the simulation environment now is not a gaming environment, but a high-fidelity physics agents such as MathWorks MATLAB that enables us to model the energy that the wind turbine is going to generate. Now, the objective in this case is we're trying to get the best energy out of the wind turbine as fast as we can. And we keep doing this over and over again in a simulation environment. And at the end, we finally learn how to deal with the high winds or maybe the slow ones. And with that, we can have an AI agent that you can deploy in production and knows how to deal with the high winds, slow winds, and having your wind turbine work more effectively and efficiently. These are just a few examples of different use cases that we can make business improvements by using reinforcement learning. And if you've been tinkering with DeepRacer, then you are halfway there. The next step is to use the Amazon SageMaker Notebook that you can use to take these 4 different components and enable you to take the next step in your journey in your deep reinforcement learning. Before we end this session, I'd like to share with you a few things about DeepRacer League. Accenture is a global professional services company with a deep history of helping customers around the world build artificial intelligence and machine learning powered solutions with AWS services. Together, Accenture and AWS bring the best of both worlds to accelerate innovation in the cloud. In 2019, Accenture launched the world's largest private DeepRacer League to date. And in 2020, they hosted their global private league virtually. Learn more about AI with Accenture at accenture.com/AI. Thank you very much for joining us in this session, and I'm looking forward to hearing about how you can use today's learning on replicating DeepRacer with Amazon SageMaker, modifying neural network architecture, and using DeepRacer Notebook, and use all of the knowledge to improve your business use cases. As always, if you have any questions, feel free to reach out to me on Twitter or LinkedIn. And also, please complete the session survey to give us your valuable feedback and help us to improve your AWS Summit experience in the future. Once again, thank you. I'm Doni Prakoso, and see you on the track.